We need to add a little bit to what was in the previous videos on arrays. So we know how to use basic arrays of primitive data type, but I'm going to kind of zoom in on one particular situation, the situation where we define an array data. We're going to keep the same name. And this time, the data type of the element in data are a single character. Each element in the array data is a single character. So I could do something like char data index 5, okay? So I want an array of 5 character, and then I can say data index 0 equals single character A, data index 1. I regret choosing 5 for a size, but I'm going to do it with cut and paste so that it's not going to be so bad. C, D, and E. And I need to change, of course, the indices here. 2, 3, 4. Okay? So I could do something like this. So I have the sequence of letters A, B, C, D, and E, the sequence of characters A, B, C, D, E, inside an array of size 5. Okay, an array of character. Perfect. Well, that's starting to look like text, right? A sequence of character. Yeah, that's what other language call a string of character, right? A piece of text, a word, a sentence, a whole paragraph, etc. So yeah, I can store text in my arrays like this, and then I can display the text by using, for example, a for loop here for size t I, starting at index 0, I lesser than, so my size is 5, I plus plus, and I told you, it's not that good to write the size like that here, and then hard code it again here. So I showed you how to use a variable. I'm going to show you another trick now. I'm going to show you how to define, and the keyword is hashtag define, pound define, okay? How to define a symbolic constant using a precompiler directive. And the precompiler directive we're using here is not pound include, of course, it's a new one, pound define. So when I say pound define and I say something such as length is 5, okay, so a name of a symbolic constant, and the tradition wants us to spell it all uppercase to make it easy to spot this is a symbolic constant, and then the value that it needs to have. And this is not actually the same thing as defining a variable. This is not a variable. This is just pretty much a glorified query replace operation that the precompiler is going to do for us. Everywhere I type the word length, the precompiler is going to replace that with whatever I mentioned here. So it's kind of like a macro, okay? It's not kind of like a macro, it is a macro in the C language, okay? So I'm using this to be able to very easily change the length of that string everywhere I want in the program. But watch out, if I use anything, lesser than 5 here, there would be a problem. So I might as well put a comment here and say the above should always be greater equal to 5. Okay? All right, so I'm going back to my loop. I have the basics for my loop. What do I want to do? I want to display, right? Printf, and I'm going to display what? Each element one after the other. Each element is of data type char, so I display with a format specifier %c, character. Okay? I'm going to display a character at a time with a space afterward, and I'm going to access data index I, so each character one after the other, and then after that I'm going to just display a new line, and then I'm done with my main function. Let's go here, gcc a.out, a, b, c, d, e, okay, we're good. Okay, so I can display some text. I can initialize an array with letters to represent some text, but I need to constantly know the size of the text, so this is a little bit annoying, okay? I would much prefer to be able also to give my text, not character by character. Imagine that I'm trying to enter here the first page of a novel. You really want to do it like that? Doubt many of you are interested in trying this. So I need like more practical notations pretty much, okay? Easier notation to accommodate the fact that yes, I'm using an array, but I'm using an array that I want to use as a string. Okay, so let's see what we can do in C. So I'm going to get rid of that length here, and I'm going to say I want to declare an array named data of size unknown for now, but you're going to be able to figure out the size because I'm going to give you here a list initializer. And this is, okay, a little better maybe, not by much. Okay, I still have to type a lot of stuff to just say A, B, C, D, E, okay? And then I have to use a loop, and the loop here needs to actually go over the length of the array, so I need to still know the length of the array. There's really no practical way to measure it here without using things that we haven't introduced, I should say. So I'm going to keep track of the length of the array again with the symbolic constant length. And then I'm going to display every character one at a time, and so on and so forth. So it's barely better than what I had before. I'm going to try to compile it, make sure it works, and then we're going to move on to something better than this. Okay, so the only thing that I got rid of is having to specify the size here, but I still have to track it down when I display the element. The next thing I'm going to do is I'm going to replace this initializer list syntax with what is called a string literal. A literal value is a value that you type in your code literally. Like for example, here I put the value 5. Literally, I wrote 5 in the code. Here, I'm going to put the string of character A, B, C, D, E. Literally, I wrote that string of character in the code. It's not read from the user. It's not computed with a formula. It's not the return value of a function that I call. It's actually the value literally hard-coded inside my program. We call those literals. And this is a literals of data type string because it's a string of text. Okay? So the double quotes do that. When the C compiler sees double quote, it knows that you're about to give me a sequence of characters, and these are going to constitute a piece of text. And then can I continue and display those things like this using the length of 5? Sure thing. Let's save. Let's compile, run. It's still working. But now, because I use this notation, something more happened. The something more that happened is that when you store actually a string of character inside an array in C, the C language uses one extra character at the end. That extra character is a character \0. So if I wanted to write it, I would write it like that. Single quotes, \0. That \0 character is a very special character. It has a meaning that is end of string. That's what it means. When the C language adds this character, it adds it after the last character of a string of text that you specified. So here I have A, B, C, D, E in memory, and then I have that \0 special character at the end. That's what marks actually the end of the string. Well, since we now have actually here an array of size 6, because A, B, C, D, E, special character to mark the end of the string, right? Since I have an array of size 6, I'm using a little bit more memory, but I should try to benefit from the fact that now the end of the string is marked like so. So I could, instead of tracking down the length, which is kind of awkward and error prone, I could say here, well, let me do the following. I'm going to do a while loop, okay, and I'm going to say I need a size t equal 0 here before to start my while loop, and I'm going to say while data index I is different than the special character. So I'm going to look at every element of my string stored in the array data, data index 0, data index 1, etc. And I'm going to display each of those characters one after the other, as long as I am not seeing the special mark that means the string is over, the string is ended. Okay? So this is what this while condition does for me. I display as a character data index I. I increment the index I at the end here, and let's try this. Save it, compile, run. A, B, C, D, E, again, working the same way. So we got rid, with going from notation to notation, okay? We first got rid of having to specify the size here. Then we got rid of having to specify the size at all by actually initializing the array with a string literal. So when we initialize with a string literal, we mean that this content is going to be used as a string of text. So you see the difference between an array of character and an array of character that contains a string. An array of characters literally contains characters. So for example, A, B, C, D, E. Okay? An array of characters that is used to contain a string will contain A, B, C, D, E, plus a special marker at the end, a special character that means this is the end of string. And that little difference makes a world of difference because now I can type text here, for example, the bird flew away in the morning. Okay? I can have arbitrary long text. It's convenient to enter. I just put double quote, like in any other programming language. Okay? So I put whatever text I want here between the double quote, and I don't even have to know the size of that text, the number of characters inside that text. Whenever I want to display it or do something on every character of the text, I just look for this marker that tells me that the string is over. And when I encounter it, I know that I need to break out of my loop, displaying each character one at a time, or my loop changing each character one at a time, or whatever my loop is doing. Okay? All right. So where can we go from now? So we have like already an interesting toolkit. The last thing I'm going to dispose of is this loop. Because really all I want to do is I want to display my entire array. And I want to display it how? As a string. Okay? Can I do that in C? Well, let's figure it out. Let's check it out. So I'm going to remove all of my loop. So see how easier it's getting, right? There's less and less stuff for me to keep track of. And now I'm saying pretty much when I want to display the whole thing, I just say printf %s. %s is a specifier for a string, format specifier for a string. So I compile, I run, and it's working. So the whole concept of string, one could say that the C language doesn't have a data type string. At least it doesn't have a data type string in the sense that, for example, the Java programming language does. Okay. Here, what makes a string in C is first an array of character, and more specifically, an array of character that stores one more character than the message needs, and that one more character is at the end, and it's a special character, and it's \0 to allow the code, every function like printf, scanf, etc., that manipulates strings is going to look out for that \0 or add it, in the case of scanf, just so that everybody agrees that this is how we are going to represent a string, and then you can pass that array of character with a bonus character at the end to any function that is expecting a string, and it will know what to do with it. Okay, so I just mentioned here that we could write or read strings. What if I want to read a string from the user? For example, what if I want to do something such as printf, what is the name? Okay, I want to prompt the user to enter their name. Now I want to read that, so I want to do a scanf, and scanf is as %s as well for strings. Okay, and then I can specify here, for example, data. Okay, but how do I define it? So I'm going to define data as an array of character. Okay, and this time I will have to give a size, because my array of character here, when I define it on line 8, it's going to be empty. That means that it can hold, for example, let's say 4 characters. Okay, but right now I'm not going to bother even initializing those characters to anything, because next line I want to read this information from the user. Okay, so scanf %s data, is going to read from the user a string, so a sequence of character, then it's going to store that sequence of character inside an array of character named data and add that \0 at the end. So this has a bunch of consequences. So let me finish up this program and then we're going to run it and talk a little bit more. Your name is, and we're going to display data. So let's try to compile it and run it as it is right now. Compiles, run, what is your name? ABC. Your name is ABC. Sounds like it's working, right? GCC, I don't know why I recompiled it. What is your name? John the third and a half. Your name is John. Huh. What's going on here? Well, the size has to somewhat match what the user is typing. But I know the size at compilation time. I decided my size was 4, and I'm going to know what the user typed only at runtime. This is actually, from a security perspective, this is a nightmare. This is a nightmare because scanf is going to read everything that you type, and is going to try to shove it in memory inside that array that is small. My array can accommodate 4 characters. 4 characters, that means 3 characters for the message, and that \0 at the end to mean the string is over, right? So that's it. That's what an array of characters can accommodate. But here, I'm going to read names that are arbitrarily long, okay? And I'm going to try to store the data inside that array. That means that I'm going to put the first letter at the beginning of the array, first element of the array, the second letter as the second element, third, fourth, and then when I reach the end of the array, I'm going to keep writing in memory more of those letters that I read. And the memory past the end of the array doesn't belong to the array. Maybe it's another variable, maybe it's anything, and it's going to be overwritten by my long string, okay? So in this case here, because I typed John the third and a half, with spaces, scanf %s read the first word, and stopped there. But if I type John the third and a half, okay, like this, there you go. This is even better, right? So now it read the whole thing. %s didn't stop at the, %s stopped at the first word that it read. So it stopped when it encountered a separator like a space. But since I wrote my long name, without using spaces, then it read the whole thing, John the third and a half, and then it tried to store that huge name. I don't know how many characters that is, but that huge name into an array that was supposed to accommodate 3 characters plus a \0. That's not going to fit. And actually, when we run, we have what we call a codum. Okay, so pretty much my application just crashed. And it even, for security purpose, it even told us that it detected that we were going to try to do some stack smashing. So I will put some link, maybe this module or next module when we talk about pointer. I will put some link for you to explore on your own if you're curious what stack smashing is. Okay, it's pretty much the root of a lot of exploit in security, computer security. So the textbook mentions a little bit about that as well. But what we are going to do right now, we're going to fix this. Okay, I want to be able to read a name without crashing my program. First solution that I have, we are going to refer to those kind of arrays as buffers, right? They are meant to store some data. Make it arbitrarily large. Okay, so I'm going to use the trick that I learned last video. Pound define length. The length is going to be, let's go nuts, 1,000 characters. So I'm making it super large so that hopefully I can accommodate whatever the user is typing, right? If I do this, let's save, let's run. What is your name? John the third and a half. So this is definitely less than 999 character. And I'm saying 999 because I still need one more characters worth of storage to put the \0. And this time it's working. Inconvenience of this, yeah, I have like an array that is 1,000 element, and I store maybe like 20, 15 characters in it, that's wasteful, right? But that actually illustrates something interesting about strings in C, is that when you have a string in C, for example, my array data here, okay, my array data is going to be very big, 1,000 character, okay, so I could store up to 1,000 character inside that guy here, okay, so starts at index 0, last element is at index 999, and what's happening is that if I try to store a string that just says character H, character I, and that's it, hi, then this is going to be character backslash 0, and whenever I do a printf of the string, like I'm doing here on line 13, whenever I do a printf of the string, remember how strings work in C, right? Strings are just arrays of characters. So here's an array of character. It's huge, okay? But the way that I use that array of character is I store each of the characters of the message one after the other. So printf is going to display the H, display the I, and then it's going to stop when it encounters the mark of end of string, the backslash 0 special character. Okay, and that's it. And all of those slots for more characters, they're just going to be ignored because they are past the end of the string. So that's how we use a buffer, right? We use a variable that can store, like, I don't know, 1,000 character, 10,000 character, right? But inside, what we use really is up to 10,000 character for storing a string. And because of that backslash 0 convention, that works just fine. And every function is going to look at this and say, oh yeah, it's an array of string, but I don't really care about its maximum size, right? I don't care about its full size. I care only about the sequence of character in there up to backslash 0, and then I'm done. This was my string. Okay? All right. Can we do any better than this? Well, let me see. We have a scanf here that's going to read anything the user is typing. That's not safe. Okay, I already mentioned that. So is there a way to tell scanf, I want you to read up to this many characters from the user? Like, let them type whatever they want, but then extract only from what they typed, for example, 5 characters only. And I want you to read those 5 characters, slap a backslash 0 at the end, and that's going to be the string that you read. Okay, can we do that? Yes, we can. So this is how you specify that length. You specify it between the percent and the S symbol, okay? And you say, for example, %5s. %5s would mean I'm going to read only 4 characters. What about John is 4 characters? Let's use a 4, okay? I want to read only 4 characters. No matter how big of a word the user is typing in response to my prompt, okay? That's what I want to read. And that would allow us to safely downsize to, so if I want to read 4 characters, right, it's 4 characters plus the backslash 0, so that would make my length 5. This time I have the smallest array that can accommodate what I'm claiming I'm going to read here. Okay, I read 4 characters, I need one more to put a backslash 0 at the end, so I need a length of 5. Let's give it a try. Save this. Run it. So what if I type just John? Your name is John. Looks like it's working, but I kind of cheated because I knew that it was 4 character maximum. I gave 4 character maximum. So let's make it a little bit more interesting. John the third and a half. There we go. That's the result of scanf %4s. Okay, scanf %s means I'm going to read a string that you type. So everything I type, and then I hit enter. When I hit enter, all the characters that I typed up to the first space are read by scanf. That's what %s does. And then try to shove it into the array. But wait a minute, here I didn't say just %s, I said %4s. So I read the 4 characters maximum. J-O-N-H-N, John, and then I store those in the array with a backslash 0 at the end. My array is of size 5, we're good, okay? What else? So %4s, well, the last thing that I could try just to play around is a.out, what is your name? Hi. Your name is Hi. So as long as I don't go, as long as I don't go overboard, everything I type is going to be used, okay? But up to 4 characters plus the \0. So it's pretty much, you should never read strings like that and store them in arrays like so, without having this percent followed by a number followed by s in order to prevent misuse pretty much of your code. Okay. All right. So we learned to use characters, arrays of characters as basic arrays of characters at the beginning of the video. Then we learned to use them as holders for strings. Okay, we're going to wrap it up here for this video. You know the drill. Forums, Piazza, as usual, depending on what we're using this semester in the course. But even more important, don't hesitate to jump in during office hours. Come see me, come see the TAs if we have any this semester, and we'll be more than happy to answer your question and help you explore this. This part is very important because we are articulating, we're moving from basic arrays in C to basic arrays used as string, and then next module we're going to cover pointers. And once we are done covering this triad, arrays, strings, and pointers, you are going to realize that these three things are really close to one another, but they are not exactly the same. And this is a source of a lot of errors and a lot of confusion in C programming, okay? So for now, we are taking it easy. We're just basically defining arrays that contain string, displaying them, reading from the user some data, putting it in such arrays. But stay on track, okay? Don't let anything slip by, because even the smallest possible details are going to be super relevant as we dig further and further into this topic. All right. As usual, thank you for your attention, and I'll see you in the next video.